Good morning, everyone. We already have discussed about client server paradigm. In this video, I'll be discussing about how we can actually software engineer a service in the client server paradigm. We'll be looking at the architecture of distributed systems, okay, which we have already discussed in detail. So I will quickly brush through it again. And then I will be looking at an example protocol, datetime protocol. And I will be discussing how this client and server for this datetime protocol can be developed using connectionless datagram sockets. So we have actually seen the architecture of distributed applications. So there is this presentation layer, okay, which actually provides this user interface for you, okay, something like web pages of a shopping cart application, etc. And then the application logic, which actually takes care of the background business, okay, business logic. So how you can actually calculate the total cost of the items, delivery, taxes, etc. So this actually is dealt by this sort of application logic. And the service logic actually takes care of underlying services that are actually needed to support the functionality. So the examples include data access facilities, directory services, inter-process communication, how it is actually being performed is actually taken care by the service logic. So now if you are thinking in terms of client server based applications, most often from the client side for developing that particular software, you need all these sort of presentation, application logic, and then also service logic. But most often for the server side software, you don't need the presentation logic. You only need the application logic and the service logic. Okay, we'll be seeing this one with the example. Okay, so as far as the example is concerned, let us look at one of the protocol. Okay, so the datetime protocol. In the previous video, we already have discussed client server based applications. Okay, most often are request response protocols, text based protocols. Okay, and you will be following a specific protocol for that particular communication. So this datetime protocol is actually defined in this RFC 867. Okay, so this is request for comments. Okay, so these are IETF documents. Most of the internet protocols are actually defined with these RFCs. Okay, so this datetime protocol is actually defined with RFC 867. So there will be a client and there will be a server. Okay, so basically this protocol defines the server will be sending a message to the client. Based on the protocol, the data representation of the message is a text, which is actually character strings, okay? And the data format which the server will be sending to the client will contain a timestamp in a format such as Wednesday, today's date, October 27th, and then 9:15 a.m. Okay, so and 2021. So this is how basically the datetime protocol, the RFC actually defines. It doesn't specify how you should be implementing this one. Okay, implementation is actually left to you as long as you actually stick to this protocol. And this is basically a sequence diagram here. Okay, so to make it simple, we are not giving the event diagrams, but rather we are going with the sequence diagram here. Now let us try to implement datetime protocol using the same client and server. Okay, but then with slight modification. Okay, so because we want the response from the server, so the client has to send some message. So there is a request and there is a response here. Request is M1 and response is M2. The data representation, again, we'll be following this sort of text or character strings. Okay. For the data format is concerned, M1 is basically a null message. The client is just requesting the server with nothing. So it is a null message. The contents, whatever you send, will be completely ignored. Okay. And the response, whatever we are getting, is exactly as per the datetime protocol, which is actually defined in the particular RFC. So this contains a timestamp in the format, something like Wednesday, again in the same format. Okay, so this is the protocol we will try to implement. And we will try to apply the software engineering things which are actually required for developing this sort of distributed application. Okay, so we will look in terms of all the three layers. So when we are trying this to develop this datetime client server using this connectionless datagram socket, okay, so at the client side presentation logic, we have this datetime client one.java. This class actually encapsulates the client side presentation logic. It provides the user interface for the client to basically provide this information. So the client can actually provide the server's address. So some means you can actually get that information from the client, okay? Because you are actually creating at the end of the day, when we are trying to implement this sort of datetime protocol using this client and server, we are establishing a datagram socket here, another datagram socket here. Okay, so and then we are actually exchanging the messages. Of course, like in this case, like we are actually trying to implement with the datagram sockets. We can also implement that one with the stream mode sockets, which we will be seeing in the next example. But let us first look at this sort of datagram sockets, because ultimately you have to implement this protocol somehow or other. Okay. Regarding the distributed computing paradigms, whatever we have learned as of now, we have learned messaging. Okay, so using this sort of sockets. So let us use this sort of datagram sockets for the time being. So we are establishing a datagram socket at the client side and also at the server side, and then like we are exchanging the messages. So at the client side, so for that time client1.java, as we have already discussed, like it has to get that information of the server sockets, okay, address, okay, and it should somehow be able to display the timestamp once it basically gets the response from the server. So basically like it has to specify the server's address and it should be able to display it. So that is the basically like client side's presentation logic. To obtain this timestamp, it actually calls the method of a helper class. So datetime client helper1.java. This method actually hides the details of the application logic and the underlying service logic from this sort of presentation logic. Okay, that is how like basically you are modularizing this datetime client one, and also like you are separating it from this sort of helper class. Okay, which actually takes care of this application logic, and of course the service logic it basically takes care. Okay. In particular, like the programmer's datetime client1.java need not be aware of which socket types are actually used for this interprocess communication. So by separating like this one, okay, so whatever your main class, datetime client1.java, don't even have to know like in which way like you are actually taking care of the interprocess communication. In this example, we are taking care of the datagram sockets. You don't even have to know like it is actually using the datagram sockets. Let's try to look at this datetime client one. Okay, so this actually takes care of the presentation layer. So of course, like it is actually getting the input stream reader and then like buffer reader. So all these basic things like we have discussed and when we were talking about the sockets, okay, in the previous chapter. So we don't have to worry about all the things. I assume like you actually know about all the things. So all we are doing in this sort of presentation layer for the client is we are actually asking the client what is the server host. Okay, so you have to specify the address of the server. You also need to specify this sort of port number. Okay, and if you don't give any specific address, then by default like it takes localhost. And if you don't specify the port number, it basically runs on port number 13, which is the standard port for the datetime protocol. So of course, like once you have this information, then you are actually using the datetime client one helper one dot get timestamp, and you are basically giving the host name and the port number of the server socket of the server, more or less. Okay, the client don't even know like whether it is actually using sockets or not at this moment. So then that's about the presentation logic. Then from the client side's application logic is concerned, this datetime client helper one.java, which was called in the first class, actually encapsulates the client side application logic. This module actually performs the inter-process communication for sending the request data and receiving the response data. For that one, it actually uses another specialized class, myClient.datagram socket, which actually extends the datagram socket. So this type of modularizing the source code we have already seen in the examples in chapter 4. Okay, so we were extending the datagram socket, and then like we have this sort of sending and receive methods there. So by putting this sort of application logic, the details of using the datagram sockets are actually hidden from this module. See, we'll be using this myDatagram socket, but we don't know like myDatagram socket actually does the inter-process communication for you. That is actually taken care for you in the service logic. Okay, so that's how like you will actually get this sort of myClient.datagram, okay, which actually uses that particular socket for you. So let us look at these two things for you. Okay, so basically like in the application layer, you are not worried about the inter-process communication, especially like say for example, you don't have to deal with the byte array which you have to populate, okay, which actually carries the timestamp for you because you got the response. The response you are actually reading it in the byte array. Okay, so this the timestamp which you got in the byte array. In the application logic, you don't have to worry about that one. It is the process, it is taken care by the service logic for you. So let us first look at the application logic. Okay, so datetime client helper one.java. Okay, So in this case, like this takes care of the application logic for you. Okay, so you got the server's address. Okay, so and also the port number, and then like all it is trying to do is like my client datagram socket. Okay, my socket, new my client datagram socket, and then like basically like my socket dot send message. Okay, it is actually trying to send the message for you. And again, like you don't know the send message here. It is actually taken care by the my client datagram socket.java, which is actually the one which is actually taking care of the service logic for you. Okay, and it is only the service logic part of the client side actually knows like you are actually using the datagram socket. Okay, so that's how like you are actually using creating that class object, and then like you are actually sending the message. You have the server host and server port, okay, which you got from this presentation logic, and you are actually sending an empty message, okay, because like for the request like you don't need any message there. And then like you are receiving the message, which is actually the timestamp. Once you basically receive the message, you are actually closing the sockets, and then like you are just of course like you are actually returning the timestamp to your presentation logic. Okay, that's what like you are basically getting the timestamp. Okay, so which you will actually return it to your client one.java. So in the service logic, this is where like actually the inter-process communication is actually happening. So your my client datagram socket actually extends this datagram socket. Okay, we have actually seen this sort of implementation in chapter 4 already. So we actually take the datagram socket, we actually port all these sort of port number and then like the things. And then like when we are actually sending the message, we actually create a datagram packet with this buffer. Okay, you already get the message and you basically create this sort of byte array with this message.getBytes. Okay, and you create a new datagram packet with this that byte array and then like the length and then like receiver host and receiver port. That's what the server host and server port in this case. And then like you will basically datagram socket dot send of datagram packet. So that's it. The packet will be actually sent for you. Okay, by calling this one. Okay, we have already seen this one. And then like similarly, you can actually receive the message. Once you basically receive the datagram packet, okay, so you need to basically create the byte array, and then like you actually receive this sort of buffer into the byte array. Okay, when you basically call the receive datagram. Okay, so basically like on the particular socket, like you are actually calling to receive the datagram, which is actually we have seen like it is a blocking receive, and here you actually get the datagram packet. Once you basically get the datagram packet, you are actually reading the message, okay, from this buffer, and this is the message which you are actually returning. So basically like your service layer is actually taking care of all the inter-process communication. Okay, so taking care of this sort of non-blocking send and blocking receive and everything. And your application logic, okay, don't know about this one. It is actually saying like it is sending some message and like receiving some message. In fact, actually it is sending a message which is actually empty for this particular protocol for the daytime protocol. So this is how like you actually separate these three. So the presentation layer, okay, presentation logic, application logic, and service logic. And this is the UML diagram for this particular daytime client, okay, using the datagram sockets. So you have this sort of daytime client, okay, so which is the sort of presentation logic as we have already seen, and daytime client helper, which is actually taking care of the application logic. And the actual inter-process communication is actually happening in this my client datagram socket.java, which actually takes care of this sort of service logic, which actually has this sort of association relation with this datagram packet. So you are actually using the datagram packet here. Of course, same sort of association relationship exists between the daytime client one and then like daytime client helper one. Okay, so we have these sort of associations, okay, here as well. And this my client datagram socket actually is extending. So this datagram socket, so we have this sort of inheritance relationship. Okay, so we are using the packets, and actual sending and receiving the message methods are actually in this my client datagram socket class. So this is this sort of UML diagram for the client side. Now let us look at the server side. Before we actually look at this sort of server side, okay, let us see like what are the advantages of separating these layers. Okay, so these logic layers, we have actually separated them. What are the advantages by putting the source code and developing it like that? These things actually allow each module to be developed by people with special skills or expertise. Say, for example, software engineers who are actually skilled with user interface development, they can take care only of the presentation logic. They don't have to worry about the sort of application logic or the service logic. Similarly, like people who are actually experts in this sort of application logic can take care of that one. Here, for this particular protocol, it is very simple. You are just sending the message. Say, for example, in the application logic, you can take care of some complex tasks as well. Okay, so it is up to you. So you can basically read it, the data from the client, and you can actually take care. Say, for example, like you can add additional messages, etc. Okay, or like you can actually do additional logic, application logic, which is actually taken care. That can be taken care by an individual person, another person. And the service logic actually needs the expertise of inter-process communication. This can be done by another developer. So in a software company, like several people will be having different levels of expertise with different things, and they can take care of that one. We have perfectly modularized with this sort of separating this sort of layers. Okay. Not just that one, you can also modify each and every logic separately. So if you make any changes in the presentation logic, it don't have to influence the other two layers. Okay, say for example, in this case like application logic and service logic. The same thing happens as well. So if you want to change anything in the application logic or the service logic, it don't have to influence the presentation layer. Okay, so these are the advantages of separating these particular layers. So now let us look at this particular server-side software. So again, let us look at the presentation logic. I have already mentioned like typically there will be very little presentation logic on the server side. Okay, in this case, like all you want to get from the person who is actually starting the server is just the port number where like you are actually trying to run. Okay, in our example, like we will handle it by taking it from the command line prompt. So then for the application logic, we'll have this daytime server 1 class, okay, that actually encapsulates the server side application logic. This module actually executes in a forever loop. That means like it is actually waiting for the request to come from the client. Once it basically the request comes, then it has to conduct a service session for that particular client. The session like we have discussed in detail in the previous video. Okay, so how you actually establish the session and how the communication between the client and server you will be actually taking care within that particular session. Okay, at the server side. So for sending the response, okay, back to the client, it actually uses again like this specialized class, my server datagram socket. Okay, so which is again extending this datagram socket. And again, by doing this one, the details of using the datagram sockets are actually completely hidden from this application logic module. So it is the my server datagram socket.java class that actually provides the details of the inter-process communication. That means like it takes care of the service logic for you. Okay, so that is the one which is actually using the datagram sockets for you. So now let us look at this sort of application logic. I mean like the presentation logic and the application logic layer. Okay, again like you are trying to get the port number from the client at the server side. So if you are not specifying the port number, then by default like it is taking 13. Okay, so that's where like the daytime protocol actually runs. Okay, and then like you are actually creating this sort of my server datagram socket. Okay, and then like you are actually sending the port number for that one. And then like you are in this sort of infinite loop. Okay, so of course like your printing daytime server is ready, and then like you are actually waiting in this infinite loop. And then like you are actually creating a datagram message. So this is again a support class where like you are actually putting the message. Okay, and also like client information. The client socket is there, the server socket is there. In the previous classes, okay, so with the client side, you have actually sent the datagram packet here. So by taking the datagram packet, you can actually get this sort of address and the port number from that particular datagram socket. Okay, how I will tell you later. Okay, and then like you are also sending message from message also has to be stored. So all that information is actually stored in this datagram message class. Okay, which is just a support class for you. Okay, let me show that one to you in the implementation actually. So this is the datagram message, which is just a support class. Okay, so all you can do is like it has this sort of message, whatever you want to prepare. Okay, and it has this sort of sender's address. That's what I was actually trying to tell you. So basically, like when you have sent a datagram packet to a server, from the datagram packet, the server can actually get the address of the socket of the client from where like the message is actually received, and that message, okay, whatever we want to send back, okay, and then like the server's the sender's address and the port number you are actually storing in this sort of support class. You don't have much information there. Okay, that's why like I didn't drag it onto the slides. Now coming back, okay, so what you are doing is like once you have you are saying basically like once you have received a request from the client, okay, so you basically are trying to receive the message and the sender, okay, from the client, okay, by using this sort of the socket, okay, so which is my server datagram socket, which is the support class, which will is actually taking care of the service logic for you. Okay, and then like you actually get that message whatever you have received, and also the sender information from where like you actually received the message, so the client's socket's address actually. Okay, for your understanding I'm actually trying to tell you that. So then you can actually say like you have received a message, okay, and you are actually ignoring that message because like the message is empty. All you are interested in is actually receiving the sender details, okay, because like you have to send the response back to that particular sender. Using the datagram packet you can actually get the information of the sender. So once you got that information, okay, so using this datagram message, once you have that request, okay, the datagram message you are actually using it in the request, okay, object, and then like all you are doing is like you are creating a date object, okay. From the date object you are actually getting this sort of timestamp dot to string, okay, and then like this is the message which you are actually trying to send using this particular my server datagram socket. So my socket dot send message, you are actually getting the request, and then like from there like you are actually getting the address of the sender, that is the client here, okay, and the port also like you are actually getting it, okay, and then like you are actually putting the message, and this is what you are actually sending it to this my server datagram socket. And the my server datagram socket is where like you will actually try to get the address of the client from the received datagram packet. So in the API, so you can actually get the address and the port number from the datagram packet. So once you receive a datagram packet, okay, you send from the client to the server. At the server side, like when you have received the datagram packet, from the datagram packet, by using this particular get address, you can actually get the address of the client socket from where like you actually received that particular datagram packet. That's actually interesting, okay, and also like you can actually get the port number of this particular client. So using this address and the port number you can actually send a response back to the client. Okay, that's how like you are actually sending the information of the client to the server, so that like the server can send a response back for you. Okay, so these are the methods which you can actually use, and that is what is actually being used by this my server datagram socket, which actually extends this datagram socket. Okay, and then it is actually taking care of the service layer for you. So the send message is pretty much the same. You are actually creating this buffer with whatever the message like you want to send, and you will actually take care of creating the packet for you. Okay, and then like you will be sending the packet on that particular datagram socket. From the server side you can actually send it back. So that means like it will reach the client, because now you already have the address of the client receiver host and then like receiver port for you. So actually the receive message is the one which is where you are actually receiving the message from the client and you are actually trying to extract the details of the client. Okay, that's what like the earlier API which I have talked in the previous slide. So in the receive message and sender, what you are doing is just like the way like earlier we have learned, like we are actually creating a buffer, okay, byte array, and we create a datagram packet with that particular buffer, and then like we are receiving that datagram packet. So that means like by now like you have already received the message, and here is the interesting thing happening. Okay, so we created this particular datagram message, okay, which is like return value or new datagram message, and then like you are putting this return value dot put value, the whatever the message like you have received, okay, in this case like it is empty thing which you have received, and then like this is the client address, so datagram packet dot get address, so this is the client address and the client port, okay, and then like you are creating that one, and then like this is the one which you are actually returning. My server datagram socket is the one which is actually returning this particular datagram message, and this is what you are actually using in your original class datagram server, okay, the message like which you have received, the datagram message which you have received, and this is the one from which like to which like you are actually creating this particular timestamp, okay, and then like on your my server datagram socket, which is like my socket, you are actually sending the message by getting this particular client address from this datagram message request.get address and request.get port and whatever the timestamp which you have created, and that is how like you are actually sending the message back to the client. This is the UML diagram for this particular datagram based datetime server, okay. So in the presentation and application logic, like we have this datetime server one, okay, which has this association relation with this datagram message, okay. This is where like you are actually saving the client side address, okay, so and also the port number, okay, and it also has this association relationship with this my server datagram socket, okay, which has this association relationship with the datagram packet, okay, and it has this sort of extension relationship, okay, inheritance relationship of datagram socket, and this is where like you have the methods, so the send message, receive message, okay, these are basic things, we have already seen them in chapter 4, and the extended thing which we are seeing is like receive message and also the sender layer, the sender address also like you are getting, that is the client address you are actually getting, so that like you can actually send the response back for it. That's about the server side of this datagram datetime server, okay. Now let me try to demonstrate that to you in the source code. So this is the source code, okay. So I have already explained you all the source code, okay, in the slides itself, and here is my client, okay, and here is my server. So let me try to start my server, okay, first. So basically like I'm starting my server, datetime server is ready, so I didn't specify any port, so basically it will start on port number 13, okay, and then like let me try to start my client side, okay. So let me try to start my client. So what is the server host, it is actually asking, so this is what the information which we have to provide, so that is what is actually taken care by the presentation logic for you. So I want to connect to localhost, okay, what is the port number, I can specify it as 13, okay, and then like the client has actually sent the request to the server, and we got the response back from the server, because like it is following the datetime protocol, the server received is like we received the address Wednesday October 27th and the time. So that's it, at the end of the day like all this we have taken care is like we have a protocol and we have exactly implemented the protocol, and then like we have modularized the source code, and then like we followed a proper software engineering mechanism of developing this sort of distributed applications by taking care of this presentation layer, application logic layer, and the service layer. So regarding the reference are concerned, now we are in chapter 5, okay, with the MLU, so this distributed computing principles and application, okay. And regarding the datetime protocol, I have actually kept a reference to this RFC 867. If anybody is interested, you can go and check it there. Thank you very much for your attention.